see my screen, and then from there, we will just straight away get started. Are you guys able to see my screen? Is it clear on your side?
Yes, sir.
Okay, if that is the case, then it's fine. So just make sure that you've got your pen, paper, and calculator, because for some of the things that I'm going to be doing, I will definitely need your participation by doing some necessary calculations. So I will just be touching there and there, not necessarily focused on a particular topic or follow a particular sequence. So something that I've thought of is analytical geometry, because it includes the calculations which are almost the same as what you would do with the functions. Definitely, over time, we'll therefore dive into the functions and some more of those complicated topics such as Euclidean geometry and many others that you may recommend. They are complicated. So just to give you a quick revision, remember we have got this thing that we call a Cartesian plane, which has the x-axis and the y-axis, that center being the origin. So when it comes to analytical geometry, definitely you might find that you are given some lines which may form a shape, doesn't really matter that much, may form something of that nature. So a point could be labeled point A, perhaps that being B. You may be having another one being referred to as point C. So something very much important is for you to be aware that point A falls in the second quadrant, whereby in the second quadrant, in terms of the coordinates, we are having a negative x value and a positive y value. That falling in the fourth quadrant, whereby x is a positive value, then y being a negative value. That quadrant, negative and negative. So these are some of the things that you need to be aware of before we even get to the calculations. And most importantly, remember that line AC, when you look at it, you should be aware that it has a positive gradient, because it will end up in the first quadrant and the third quadrant. That's if you extend it, those lines will continue up to infinity in those quadrants. But this one of line AB, it is the one that has a negative gradient. So when it comes to line BC, it's just a matter of whether that line is a line which is parallel to the x-axis, or if it is a line which is at an angle. Based on that angle, we will be knowing whether it is sloping in that direction or if it is sloping in that direction. But assuming that it is a horizontal line which is parallel to the x-axis, that would mean its gradient is 0. So it's not rising and it's not falling. So these are some of the basics that we can talk about without having to do any calculations. So if the gradient it is 0, then definitely we can't talk about it being positive or negative. Questions that may be asked is something that has to do with the distance from one point to the other. Again, it could be the gradient of a particular line. Otherwise, you may be required to calculate the middle point of a certain line. Not only that, there is also what we call an angle of inclination. That angle of inclination, it is this angle from the x-axis measuring in an anti-clockwise direction. So that would mean it is that angle. Here it would be that angle. This is our angle of inclination, of which the formula for that, it says tan of an angle equals to the value of the gradient. So that means to calculate that angle, you will need to know what the gradient of that particular line is. If we are looking at the angle of inclination of line AB, that would mean it is that angle theta that you'll be calculating, where you will need to know the gradient of line AB. Then if we talk about line AC, that would mean it is that angle beta, where you will need to know the gradient of line AC. So what I've just spoken about, it was just everything that is related to, everything that has to do with the theory part. Another question that you may be asked, or something that you should be aware of, is the calculations related to the determination of the formula or equation of a straight line. So it could be that you are required to find the equation of straight line AC or AB. It could be BC, doesn't really matter that much. Or sometimes you may be given the equation of line AC and AB, and they want you to find the point of intersection. Those are some of the questions that you might need to expect. So maybe since now all that I was talking about, it was something that is related to the theory part. Perhaps let me hear from you in case if there is a particular question that was asked and you would like for me to touch on, or in case if there is something that I've explained and you would like for me to expand on. Just check if it is still the three of us. Nope. Remo has joined. Okay, then it's fine. I believe you guys are still able to hear me. And again, you are still able to see on my screen. So what I'm saying is there anyone who would like for me to expand on something? Or if you came across a particular question and you were curious as to how you can go about it. So this is that opportunity where you can just prompt me to say something. Not that I will put you on the spotlight and say, what did you do? What do you think can be done and all of that? I will just keep it simple and straight away. Make sure that I'm the one who provide the necessary information. So any questions on your side up to so far, or no questions? Hey, guys.
So I have no questions, sir.
Yes, go for it, honorable member. Langley,
Yes, sir.
yes, go for it. I couldn't hear you. Did you say you have a question or no question?
No, sir. I said I understand, sir.
Oh, you said you understand. Okay. I think I misheard you there. Okay, then it's fine. Anyone with a question or whatever the case may be? Okay, looks like it looks like we are okay. Let me just quickly do this. Okay, then it's fine. I think I will therefore, let's see, okay, maybe let me be the one to go about this one. Say, sometimes, okay, we do have that as a Cartesian plane, and then let's say now we are having that line, and then that line, it is line A, B, perhaps, let's say we've got that angle over there, and the angle that we are having there, it is angle theta, and from there, we are having that line, and that line, it is perpendicular to that line AB. So that means this would be CD. And that line CD, it has an equation, let's say, of y, which is equals to, perhaps, let's say, negative 1 over 2x minus, let's say, 4. Yes. And the question here, it is to say, find angle theta. It's a very difficult question. Okay. Mr. T, can you mute yourself? Looks like, okay, then it's fine. So here we are having a question that I've just given to you to try and work it out. I think the best way to go about it is to say, give it a try, and let's see. I'm just trying to think of how we are going to work it out, because as others are working it out, I'm just trying to avoid a situation where the other one wants to ask a question, and with me responding, it then gives others a clue. So what I'm trying to achieve, it's for some of you to just struggle with this question, so that at least when we get to the solution, you will be having an idea in terms of how to think about this type of a question. Okay, maybe let me ask, do you guys have an idea of where to start in finding that theta, or is it a difficult question? You've got no idea in terms of where to start. Guys,
I have no idea where to start, sir.
No idea where to start. Okay. Who's speaking now?
It was me, sir. Can you hear me?
Yes, but I don't know who is me. Who is
Some
me?
can see where.
Oh, some can see way. Okay, then it's fine. Then I'm aware that some can see way has got no idea. The other honorable members, I just want to have a sense as to whether this is a complicated question or if the Manyakis, not sure if Nyaki is still there. Langlihle, who else? Okay, Elsie is still there. Yes, Nyaki, Tandeka is joined. Nyaki and Langlihle, what about on your side, Bali?
So it's a difficult question.
Yo, it's a difficult question. Okay.
Sir,
Yes, Langlihle.
so I'm currently working on it, sir.
Oh, okay. Giving it a try. Then it's fine. I'm very shocked that you say it is a difficult question. Maybe it's because it's not that it's difficult, it's just that it's a tricky question. I'm glad it is a tricky question because I'm therefore going to guide you in terms of how we work out this type of a problem, or at least what to think of or how to think about this question. Okay, Nyaki, let me just choose you honorable member, just so that we will experiment. Are you still there, the Manyakis?
Yes, sir.
Okay, so this is how you approach this type of a question. So when it comes to analytical geometry and they talk about the angles, what formula comes to your mind when they talk about something that has to do with the calculation of an angle of inclination?
So the tan is equals to tan of an angle is equals to m.
Yes, tan of an angle is equals to m. Then the next question is, which m must be substituted there?
So I think it's the AB, the m for AB.
M for AB, you say, nay.
Yes, sir.
That is 100% correct. M of AB, because that angle, it is then attached to that line AB. So the angle would therefore be that one. So this line of AB, it is interacting with which line?
With CD, sir.
With CD. How are they interacting?
They're perpendicular to one another.
Yeah, so in this topic of analytical geometry, what is that formula again that has to do with lines which are perpendicular to each other?
Their product will give us -1, sir.
Yes, exactly that. So that means the gradient of that line of AB, when you multiply it with the gradient of that line of CD, they must just give us -1. So can you not somehow be able to find the gradient of line AB based on this information?
So that was the problem I had.
But is it solvable now? Or still tricky?
So I'm still not understanding.
Still not understanding. Okay. Then the question is, what is the gradient of line CD?
Oh, I see it now. So it's -1/2.
No. Gotta go to 10 triple one more. The money. Why
Excuse
why
me.
would you disappoint them?
I meant to say thingy. You're
No,
sorry,
no,
Pastor.
no, 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 no. Okay.
Sorry, sir.
But does it make sense to everyone? I want to now give you a chance to quickly give it a try and see how far you can go. But any questions, or does it make sense what I've done there with the maniakis? I'm sure all of you, you are aware of those two formulas. You just need to now apply them. Any questions, or do you need a chance to quickly try work it out?
Sir, may you please explain the formula, sir?
What did you say, Language?
Sir, may you please re-explain the formulas?
Okay, I see. Maybe let's try to do it as I did with the maniakis. Do you still remember that there is this formula which says to calculate an angle of inclination, you will therefore say tan angle equals the gradient of a line. Maybe let's start here, Langlitley. This formula, do you still remember it, or should I explain further on this one?
Oh, sir, I remember it, sir.
Yes, okay, then it's fine. So it is that one which says, if we talk about the line of AB, that would mean the angle of inclination of this line. It is that one there. But if it was then the formula for the angle of inclination of that line CD, then it would be M of CD. That would mean the angle of inclination, it would be that one. That is this formula in terms of how it works. And then this other formula, it is that one, if you remember, we were saying, maybe let me do it this way and say for parallel lines, the gradient of line 1 equals to the gradient of line 2. And then for perpendicular lines, when you take the gradient of line 1 and you times it by the gradient of line 2, they will always give you -1. So to explain this, on a Cartesian plane, this is what we are saying. If we have that line having the 2 points, and we use those coordinates to calculate the gradient, and we find that the gradient of line AB is equals to 2. If we have another line, and that line, they have done that, then we know that the gradient of line AB is parallel to the gradient of line CD. That means they have the same or equal gradients. I'm not sure if I'm losing you here, Langlitley.
No, sir, I understand, sir.
Yes, and then when it comes to that one of the parallel perpendicular lines, let's say we have this line which goes like that, and then they show us that, and they show us that. That means maybe let's say D, E, F. This is line EF. So for this one, if we only look at that section whereby we have the intersection of A, B, and that EF, what it means is that the gradient of that line A, B, when you times it with the gradient of that line of EF, they must give you -1. So this is that formula which says the gradient of line 1, when you multiply it with the gradient of line 2, it will be equals to that. Then, do you agree that here, Langlitley, we have the gradient of line AB? We just don't have the gradient of line EF. Do you agree on that one?
Yes, sir, I agree.
Then to solve or find out what the gradient of line EF is, we will therefore substitute. If the gradient of AB is 2, that means where we see the gradient of A2, not A2, but AB, we put that so that we'll find the gradient of EF. They say this is equals to -1. Then what you do is to divide both sides by that 2 so that this side it will cancel, and that's how you get the gradient of line EF, which ends up being that -1/2. Did I lose you there, Langley?
No, sir, I understand, sir.
Yes, 100%. Then you can quickly try work out this one. Let's see how far you guys will go. I'm glad that Langley requested for that, because even those who are not aware, at least you've got an idea of where or what I was doing with the Nyakis there. Any questions on that one, or are we clear?
We're clear, sir.
Okay, then it's fine. Perhaps you can, in the meantime, answer that question. Find theta for this one. I'll just give you, let me just give you 3 minutes on this one. Maybe let me just temporarily mute myself.
Sir?
I just forgot to unmute myself, but I think it was Langley. Langley, was it you, honorable member?
Yes, it was me. I tried to ask, may you please go up on your screen? I want to see the question again, see if I wrote it correctly.
Wait, is it this screen that you need?
Yes.
So you can just take a screenshot. So remember, guys, from time to time, I might be busy on this side. Just make sure that For your notes, you just take a screenshot. In that way, it will make it very much easier for you to capture the notes. Otherwise, anyone who is done, let's try and compare our answers so that we can see if we can make some progress. Anyone who has calculated theta?
Yes, sir.
Okay, what did you get on your side?
Sir, I got 14.04.
14.04. The other one, anyone who got the same or a different answer? It has to be 14.4 degrees because it's an angle. Anyone else who got same or different answer? Guys? Anyone who got the same or different answer? No response. Okay. And then the other question, the Manyaki, is what was your M for line, I think it's CD, the other M? What did you get when you were calculating it? Line of AB. Yes, it will be line of AB.
Sir, I got 1/4.
1/4. Mhm. You got 1/4.
Yes, sir.
Okay. Why am I not convinced, Manyakis? You know why I'm not convinced, honorable member? It's because normally when you calculate the other gradient, so I made it a fraction on purpose because I know that it's a bit confusing when it's a fraction, but your answer should just play around these values that you are seeing there. Because the moment you take -1/2 and you multiply it with 1/4, already they can't give you -1. The only way it will give you -1, that's if it is. Do you get my point, the Manyakis?
Yes, I do.
Yes. Then it means already this one is not leading us to heaven. Can you see?
Yes, sir.
That one, do you know that an angle it's a direction, honorable member?
Yes, I do.
Yeah, so this one definitely is taking us to hell. I'm telling you, the Manyakis. We don't want to go to hell, honorable member. Please recalculate and lead us to heaven. Yes, want to go to heaven. Anyone who got a different answer?
Sir,
Yes.
for the gradient of CD, I got 2.
For the gradient of CD, you got 2. Okay, that one is promising. And what about the angle?
I got 63.43 degrees.
63.40.
3 degrees.
43 degrees. Based on the fact that this you got 2, I would believe that answer. Can someone just verify if indeed our angle of inclination there, it is that answer?
Yes, it is.
Okay. then it's fine. Here's another one. Remember, when it comes to analytical geometry, the most confusing part is the one that has to do with the angle of inclinations. And also when you have to determine an equation of a line. Let's see. Okay. And then now, let me do that. Then after doing that, let's see, we have that angle there. So this thing is just something that I'm coming up with the hope that, let's see, okay. From there, I will do that. Nope. Let me just try and do it. Okay. And then I'm going to say that there it is 4. That one there. It is 4. Let's see, we are having A, B. This one is parallel to that. So that means AB is parallel to CD. This is how they said these things. And let's see that and that. Yes, here is the question. The question says, find alpha. Trust me, honorable member, when I say during my time, for me to work out this thing, I don't need to write it down. I just need to punch on a calculator, and in just less than 2 seconds, not less than 2, less than a minute, I'll be done. Because I know that, okay, this is like that, and then I just find that for that line, and I use that in order to find that. In case if I get a negative, then I know it means I got an angle out with that, and I'll be getting the angle on that other side. And that's how you work it out. So that means you should practice maths such that even when you prepare, you don't have to write it down. You just look at the question paper and say, this one, because this and that are that, I will therefore do that. And then I use this line to find that, and I'll take it and substitute it into there. And then because the gradient of this line, it is that one of a decreasing thing. When I find the angle, it will give me a yellow angle, but the question does not want a yellow angle, they need a red angle. That means I'll need to have to convert it from being yellow angle to being a red angle. And in that way, would have answered the question. So let me ask, do you guys have an idea of where to start? Or is it again a difficult question? Or are you still thinking about it and you want to give it a try?
So we'd like to give it a try.
I'd like to give it a try. Okay, let me not rush you guys, but let me give you some time to try and work it out. Just meet myself in the meantime and yes, Langlitley.
So I just wanted to ask, so what topic is this, sir?
So this one is that one of analytical geometry, that one of calculating the distance, the gradient, the midpoint, finding an equation of a straight line, determining the angle of inclination, and what else? Yes, when you are having parallel lines or perpendicular lines. Not sure if you remember now, Langlitley, I think you had to do it in term 2.
Yes, I think I remember, sir.
Yes, this is that same one, honorable member. Oh, just in the meantime. let's see. How far are you? Is it difficult? Did you get something? Or what's happening? Okay. I'm very much close to assuming that it is difficult, and I'm about to work it out. Okay, then it's fine. This is how one would approach it. The formula says tan of an angle equals to the gradient of a line. But in this case, it is not an angle named theta, but it is named angle alpha. It's fine. So the gradient should be the gradient of which line? It should be the gradient of line AB. But what I know is that the gradient of line AB should be equals to the gradient of line CD, because those are the parallel lines. I'm sure this proves that those lines are parallel, and again, I've mentioned it as I was drawing this. So why can't I use this point, which is 4, and that point, which is 4, in order to determine the gradient of line CD? So that means I've got the coordinates where x is 0, y is 4. Another coordinate, what am I saying? Where x is 4 and y is 0. Then I can easily calculate the gradient without me having to write the formula, you know. You can still say y2 minus y1 over x2 minus x1. It ends up giving that. Minus that is -4. That and that, it gives you 4. -4 over 4, it ends up giving you -1. So that means the gradient of that line is equals to -1. Automatically, the gradient of this line is equals to -1. Before I even go far, do you guys understand what I've done there? Or do you have some questions for me? Just want to make sure before I continue. Are we all on the same page up to this point?
Yes, sir.
Okay, then it's fine. Let's see. If that is the case, then I will need to now continue with the calculation. So that means tan of that should be equals to -1. Because the gradient of AB, I have figured out that it is -1. So now I will have to calculate the angle. So what do you get when you punch this? What happens is, if the answer that you get is a negative answer, you must just always plus it by 180 degrees. Because when you calculate an angle of inclination, it must always be a positive angle. Every time you get a negative angle, you just plus it by 180 degrees. And the reason for this is because when you get a negative angle, it gives you this angle, this small angle. And that is not the angle of inclination. That's why you have to plus it by 180 degrees, because if you know what that angle is, to get the other one, you have to involve 180, because those are the angles on a straight line. So what do you get when you do the arctan of sine, or what is it? Shift tan, -1. Let's see. Is it -45? Shift tan, -1. Yes, I'm getting -45. I'm getting -45. So angle of inclination will never be a negative angle. The moment it's negative, you just plus it by 180 degrees. And then the answer that you get will be a positive angle. Then let's just plus it by 180 degrees, and then you get 135 degrees. So can you see, you are now getting an angle that makes sense. You can't have that bigger angle to be 45 degrees because it has passed the 90-degree angle. Look at this. It went to 90 and it went beyond. So there's no way it can be 45. And the remainder, that's when you get a negative. And the moment you get a negative, it says just plus by 180 to get the real angle of inclination. And that's how you work it out, the honorable member, where you are having a question that involves lines which are perpendicular and lines which are parallel. A question will never be a straight, not that it will never, but it will, in most cases, not just be a straightforward question. Somehow, they will try and trick you, because an assumption is that you do know how to perform these calculations, but the reason why you have to attend this type of lessons is because very much important that we share with you what we have experienced. Some of the unfortunate part is that, likely not for me, but you may find that this type of questions, we failed them during our time. I probably did because I became better when I got to grade 11, and more dangerous when I got to grade 12. So, did you guys see how to work it out? Does it make sense? Yes,
Yes, sir.
Yes, sir.
Okay, maybe let me ask this question to say, based on what I've done or what I've explained, what would you guys say was the confusing part about this question? Just so that I will add it to my knowledge and be aware that such may be a confusion. Anyone who would like to just educate us in terms of what you thought could be the confusing part about this question? Or what did you learn that you were not aware of? Anyone? No response. Okay, guys, worry not. I've got this lesson recorded. In case if you want to access this recording, just drop me a WhatsApp inbox to request for the location of where you can find this lesson. Then I'll let you know exactly where, in case if you might need to refer to it in the future. Okay, guys, I think I'll just have to leave it here and say until we meet. Oh.